ways for seeing the effect of single particle size, double particle size and triple particle size Al2O3 in nylon 6 matrix and its effect on the mechanical properties of the feedstock filament. I am going to present three. We got different type of observations. So in the first case study, we are interested in the wear properties of rapid tooling with nanoscale. So since it is prepared as a customized tool for a special purpose application, right, and we can prepare it rapidly as per the requirement, we are calling it as rapid tooling, and the reinforcement is of the nano level. And we have selected one application, composite material. Biocompatible, you all understand, since it has to be used on humans, so the polymer matrix that I am going to use, it has to be biocompatible characteristics, as well as filler, which is basically abrasive media like Al2O3 we are basically using, it has to be also of the biocompatible grade, which is commercially available. So the using of this nanoscale Al2O3 particles in conducted under some dry sliding condition, in order to understand the tribological characteristics of FDM printed rapid tooling for more suitable for some of the presence of the Al2 pin. Then we allow it to move over that disk for certain period of time, then we take the final weight of this. So difference in weight per unit time, I can measure the weight loss, right. I can also, I have a system with me, I can measure the friction force, coefficient of friction, those are provided by a grinding wheel with more abrasive content. So specifically he can choose those as per the shape of the cavity, right, and that can be enhanced with some additional material property that we composite material. The wear mechanism was basically adhesion. So this is the another important difference that we came to know. This is important from a graph. Like if I work on this different loading condition, what will be the change in the wear mechanism. So if I that abrasive has been removed just by plowing it from that side. So these are some of the quantitative data we got, and based upon the wear tracks we have a just a qualitative description from where we came to know that whether the part is okay or it is going to have more wear, it is going to have less wear. So this is the another observation that we made out of this study. Is it clear? Any question till now? We have just discussed the effect of reinforcement. We observe 50% by weight, right? 50%. Just see, focus over here. I have a this. So there is some rise in MFI, right? The idea to explain this to data is here we have used only one size of the reinforcement. So that is why I am calling it as a single particle size, right? Only one grade of 120 size is basically reinforced into this, right? That is why quite natural thing, right? Then we did another thing. We used a 60%, then 50 has been divided into 3, right? So if I put the proportion like this and then reinforce in this, mechanical properties are increasing. Sometimes the tensile properties are increasing, sometimes Young mode MFI. So basically, if there is an effect in MFI, you can well judge there will be an effect on the glass transition temperature. And finally, there will be an effect on the extruded wire and its further properties, right? So let us see some more data. Again, using the same thing, we have collected some properties, like if I am using single particle size of nylon 6 with reinforced with this type of material or some sort of reinforcement, we can also change their sizes also, right? So another thing that I want to discuss with you is this is another way of representation. We have used again the percentage elongation, tensile strength, yield strength in another way of presentation with all SPS, DPS, TPS particles with different grade size. What is the effect individually, right? Now this is further interest for us. In this particular example, consistent properties, right? So their heat absorbing capacity, their enthalpy, their peak temperature, melting temperature, and then their decomposition temperature, that becomes more stable once we have a double or triple particle size reinforcement. That is another important observation out of this case study, right? Improvement in mechanical property, some mechanical property improving, some mechanical property not improving. Then another their microstructure is getting more uniform. What we observe, once we have a triple particle size reinforcement either of Al2O3 or silicon carbide in LD. Let me MFI test, same pin on disk test. So yes, this table is important. If you see over here, once I was having this 50% matrix, then I am defining here in the form of grain size, right? This is first for the case of silicon carbide. So we got first, let us say 25 micron size I put, I got some value of MFI, and similarly if I put 25 gram of 125 microns, I got this. Now by changing the different proportion of again SPS, DPS and TPS, we are getting different MFI, like in case of only single reinforcement we are getting. Here these all this shaded portion, basically we have, that is basically on those pins using that standard pin on disk operators, and we try to, why this is important, this hybridization is important because silicon carbide is costly, Al2O3 is cheap. If I only go for a single type of reinforcement, that is I go from where we can actually calculate the value of wear, even we can predict the value of MFI and similar things. Right. So if you have any problem using this RSM software for these type of modeling, I am also available. Any question? That's all from my side. Any question, please? No questions? Is it okay? So that's all from the GIAN course as regard to the input from our side is concerned. Now we will be happy to take some test from you.